show sound. Let me see. Okay. From the beginning. Oh, okay. Do I get? Let me see. Oh, where am I? Okay. Slideshow. But I just can't get it start. Okay. All right. Okay. Yeah, I was very happy with this object-oriented forth until last night. Okay, it's there's a big bug in it, a couple of bugs in it, and I think it's not it's not working properly. But I'll do the presentation anyway. Okay, I look over the internet and found many forth implement in Java. And there was even a Java OoEforth implemented by Michael Lusch in 1997. But all these things are fairly complicated and they're all beyond my comprehension. And I wanted very simple Java forth modeled after JEforth. Every fourth word should be an object. And Java should be a much better host to forth than JavaScript. And I was trying to build OoEforth as a true object-oriented forth. Okay, in this object-oriented OoEforth, I have only two types of words, primitive words and colon words. All system words are primitives, and all user-defined words are colon objects. And the way I approach it is to have a single class which will construct all the forth words as objects. And there is a big hash map which contains all the methods which executes the objects, the primitive objects. And if it is not a primitive, it will always use the nest method, which executes colon objects. And this is my goal. I want all colon objects contain linear object lists, and so that all colon object can be executed by a very simple inner interpreter, which just go to the list and execute every object in the list in sequence. And this was given to me by Sean Chen, and it's a very nice scheme to execute linear objects. But the requirement is that all the colon definitions will have to have linear lists. There's all the literals and all the control structures will have to convert into objects. So the in the scheme of Java, a program is an object. So here I have an object which is OoEforth 112, which is the file name of the Java program. And in this object, I have two stacks. the parameter stack and the return stack. And I have a dictionary. The dictionary contains all the primitive lists on boot up. And if you write more code and the colon words just add to the dictionary. And the method of this object is the main, which is essentially is the outer interpreter of forth. And then there's a class in this main object, which is called class code. It constructs all the objects. Okay, so this is the picture for this OoEforth 112 object. You can see I have the stack there, I have a return stack there, I have a dictionary which has all the forth words in it. And in the beginning, they are all the primitives, and later on you add colon words to this list. And all the objects in the dictionary has two forms: the primitives and the colon words. So the primitives uses only its name, and then it's the method. It's the big hash map. It uses the name to select the method. Okay, so the primitives only uses two fields: the name field and the method field. And colon object has name, and it has a PF method, PF field, which has a linear list of objects. And then it can have an immediate flag if it is an immediate word, and it executes next. All the colon word has a next, which just executes the colon list in the PF field. So all different types of words are basically all colon words. So a constant in the PF field, there's a do con, and the constant would be in its QF field. Okay. And then the variables and let me see, the control structures. The control structures are all colon objects, and but it has PF. It has a number of passes in the form of PF field and PF1 field and PF2 fields. I'll show you a better picture later. And in this big object, it creates the dictionary. The dictionary are instantiated, and then the outer interpreter is the main method, and the class code, which generates or construct all the objects. And here is the big hash map, which contains the primitive methods. Okay, it's too busy. So the class code is one size fits all object constructor. And it constructs all the primitives object on boot, and then the outer interpreter will use this class code to construct colon objects. And this is a much better picture of all the classes, all the objects. So here on the top left is the class code, which has attributes, the name, PF, PF1, PF2. QF is for data, And the literal field is for string and immediate, and then the method. And all the other objects are created from the class code. And the different objects would use their specific attributes if they need it. So the primitive object, it only uses the name field. It may have the flag in the immediate field, and the method is chosen from the big execution table by the name. And in the colon object, you have the name and you have the object list in the PF attribute. And the method is this nest, single nest method. And all the objects that user created are colon objects, but colon object can be configured for various purposes. For example, for an integer literal object, it is a colon word, but it has in the PF field, it has the do_com object. And the do_com object would use the value, would return the value in the QF field. Okay, the variable and the array object, they are all colon words, and the PF field contains the do_var object. And this do_var object uses the value, one value for variables, and a list of variables for the QF. So you can actually create arrays of indefinite size with this. And it is still a colon object with a do_var object. And for string literals, it is a colon word, but the PF field contains the do string or dot string, the name. And it uses the data, it stores data in the literal field. And it either return the object or print the string when it is executed. So this is the string literal. They are all colon objects, but has a embedded object doing various things. The most interesting thing of this implementation is the control structures. So we have a branch control object, we have loop control object, and we have the cycle or the for next control object. And in the control object, I use the PF field or PF attributes, PF1 attributes, and PF2 attributes to store various branches in the control structure, so that every control structure becomes a single object. And it's just that different paths in the control structure are encoded in PF attributes or PF1 attributes or PF2 attribute, depend upon the object. And each of these branch object, loop object, or cycle object knows what to do when to execute PF list or PF1 list or PF2 list. So this way, all the literals and all the control object, control structures are all reduced to single object. And so the colon object, every colon object would have a linear object list in its PF attribute. Okay, so let me just quickly scan through the primitives. Object uses only the name field and then the the execution method, which selects the execution method by its name in that big hash map table. And all the colon object has the name and it has the object list in the PF field. And when it is executed by this next method. And the literals, we have constants, we have variables, we have arrays, we have strings, and all these literals are reduced or compressed into single objects. And the constant object use do con, and then it uses PF to store its value. And do con object, which uses, do con object has the QF field for the value. And do var object, it executes do var, and it returns the pointer to this value list. And this is for list that you can have a value list as long as you wish, and you can use it to do big arrays. String object, it has the string method in the PF field, and the string objects uses the literal field, a literal attribute to store the string value. The control structures, there are branches and loops in an object list, and all control structure are colon object with alternate paths. So if it used the PF to store the true clause and PF1 to store the false clause. And begin again uses the PF, just repeat this list indefinitely, and the begin until execute the PF, but it exit until the top of stack is true. And the begin while repeat use the PF for the true clause, and use the PF1 for the repeat clause. For next, generally execute PF, but if you have after then it actually has a PF, PF1, and PF2, 3 lists to choose when the loop is executed. So the if object, branch object, use a PF1 and PF2 to select the alternate execution path. And the begin object, it do the branch, and it implements the if-else structure. And the loop object use object list, PF and PF1 for 2 alternating paths. For example, you use the begin PF while PF1 repeat. So this is the loop, and the for object, and this is cycles object. It actually selects PF1, PF, PF1, or PF2 for execution when you repeat the loop for a number of times. Okay, the outer interpreter is in the main method, and because the Java supplied much of the functions needed by the outer interpreter, so the outer interpreter is a very simple method, and especially the parser is a single function, which calls the in-next method in the scanner library. But there's a problem in using it because it just scan in next, just get the next string. It parses the next string from the input stream. You cannot very easily implement text line by line. Okay, and to use this method, I just cannot occasionally send out the OK and or display the data stack. It's not a big problem. It's a very serious problem in that because I cannot always see the stack, some problem escape me when I try to test this the whole system. So here is the main routine, which is basically the auto interpreter. So it inputted the next string, the parser, and then it tried to evaluate the idiom it parses out. So if it is if it is a word in the dictionary, it would execute it if it is not compiling, or even if it is compiling, if it is an immediate word, it will execute it. Otherwise, it will compile it. And if it is not a word, it will try to convert it into an integer. If it's successful, it will compile the integer as a literal if it is in the compiling mode, or it just leave the integer on the stack if it is executing. So this is the whole auto interpreter. And in OoEforth, I spend a lot of words are defined just to build the auto interpreter. But here, because the Java supplied lots of functions, and the auto interpreter can be coded very efficiently and doesn't need much supporting words. And the colon object compiles a linear object in the PF field. Okay, so if the linear list is, if the list is linear, it can just be executed sequentially, very conveniently. And the linear list can also be nested indefinitely. So the complicated data structure like arrays and strings are reduced to objects, and complicated control structures like branch and loops are reduced to objects. And so I name it object-oriented OoEforth. And it is you know, I was I had the loss of computing proposed many years ago. And the third law of computing is the law of structures. And it stated that all computable problems can be reduced to nested linear lists of structures. And I think the object-oriented OoEforth just prove this law. Okay. So OoEforth 112 implement the fourth words as true objects, but it is my first Java project and showed my lack of understanding of this extremely complicated language. I have to apologize for this line. OoEforth 112 is logically correct, but can use lots of improvement. I think I can use lots of improvement, but OoEforth 112 is not logically correct. The problem is that it cannot exit a word very gracefully, okay? And especially in a nested structure. So I can only exit a linear list, but I cannot exit a nested list. Okay, so that's a big problem. The problem was I didn't notice it when I try to test the system. You know, the way I test my system is to load the big 17 lesson file. And if it loads correct, it's load okay, I assume the system is okay. But because it didn't exit properly, and it cannot in the calendar application. It didn't construct the calendar correctly, and because I didn't, the problem is in the exits. When the exit doesn't execute properly, it leaves lots of garbage on the stack. And because I didn't show the stack when I'm executing, I didn't notice the problem until last night. So I would not post the this to be distributed until that problem can be fixed. But I can use lots of help in, if you are good in Java, please let me know how to exit an object gracefully, and even when this object is nested very deep in a word. Okay, let me just show you some okay, let me just get over to here, not this one. And so this is the eclipse, okay, and the code, the entire system is in one file, OoEforth 112 file. So you have the stacks and dictionary, and this is when you boot up in the main method, it construct the dictionary. Okay, so here all the primitives are instantiated here. And then this is the main routine, the main interpreter, the outer interpreter, okay? So it is executed, first constructed the dictionary, and then go into this infinite loop to interpret what's inputted in the input stream. Okay, here is the class code, which is the basic template for all the words. Okay, and here are three different constructors. One constructor just has the name. This is used to construct all the primitives. And this constructor, it takes data, a piece of data, an integer, and this compiles the object which needs integer literals in the QF field. And this method would construct an object, a string object, and this string object will be embedded in the literal field. Okay, and then this is xt, the method which executes all the primitives, and it just look up the method in this big hash table and executes it. If it is not primitives, then it uses this method to execute the list. Okay. And so if a word is exit, I would terminate this object list. But this termination is not aware whether it's nested or not. Okay, so it can only exit the current list. But if this list is embedded in another list and its exit cannot backtrack to the calling colon word and terminate that. So this is a big problem. I cannot backtrack. So I need help, okay? Somebody, if you know how to backtrack and exit a nested list gracefully, I would appreciate very much. Okay, here down is the big hash map with all the primitives, and it's about the whole thing is 508 lines. So I think I'm pretty happy with this, but it's not working. Okay, it's not working properly. It worked most of the time, but it cannot handle exit very gracefully. Okay, so that's what I have. I would let me just stop share.
Dr. Ting, you may be able to use exceptions to do this, but I'm struggling a little to understand the exact flow control pattern you need. The trouble with all these languages is they're always trying to impose a rigid, structured sort of flow to things, and so just like you hit with JavaScript, it's non-trivial to get that right flow control. They simply don't have goto underneath, right? That's the real problem. All the contemporary high-level languages put goto in the especially computed goto into sort of the box of things you're not allowed to touch.
Yeah, it's very interesting in that an object can handle everything inside itself. Okay, but an object is not aware of where it came from. And so I cannot backtrack from object to its parents. But I'm sure there must be ways to do that. It's just that I only read the first 10 lessons in my Java tutorial and didn't get deep enough to understand all the internals of the JavaScript, of the Java. Okay, so I need help.
Dr. Ting.
Yes.
Dr. Ting, to me, the interesting problem is to go the other direction, to create the higher level languages in fourth, which is intrinsically the minimal way to get to a clocked chip language. So the creation of things like doing the memory management, that's a real nub and so forth. But to me, the interesting and the valuable thing is to create the high level language all the way down, open to the chip or the processor in an FPGA, open in fourth, so you can work at any level that you want. And that's why I've implemented evolved from K, which is the highest level or the most, it reduced APL to lists of lists. And I've taken Arthur's structure on that and in many ways simplified it even more. But one of the things to be able to have the exchange between having a stack of items and a list of those items as an object, to me is, well, the whole thing is just simply, it works. But I spend all my time, I've just done some stuff implementing one of Arthur's highest level things for aggregating accounts. Because when it gets down to it, being able to, if you're really good at crunching numbers, the numbers that are most valuable to crunch are ones that have currency symbols attached. That's just what, but I like your lists as fundamental structure. And one of the hard pieces, and one of the first to do, was to take this list of where an item of a list can be a list, and then convert that to a linear form without redundancies that you can store as a file. And that was absolutely the first piece of code I did back when a friend gave me a pass to an APL conference in Naples.
The problem is the platform. Okay, Forth has to have a platform, a physical platform for its execution. And I just like you said, if I have the option to get down to the bottom level of the CPU, I would love it. Okay, but this when you construct everything on a platform, not of your own design,
right? This is
take advantage of it. You can take lots of advantage of the platform, but there are something in the platform. If you cannot get through it to the bottom of the CPU.
Yeah, this is one of the, from the time I first heard of Forth, my immediate thought, and this is 1982 or so, when Tron first came out. I even recommended to Ryo Osaki, who created the Ampere notebook, pure APL notebook, that he ought to look to Forth as being the foundation for his environment, because it's the only thing. And I mean, to go and write a Forth in C didn't interest me. It's why I chose Riva. One of the reasons was because it was open to the x86. And that's what I didn't know, how you got off the ground. And to me, that's the brilliance in Forth, open.
If I may, the fourth chip that looks most interesting to me is the EP32 by Mr. Ting. I don't know. Is anybody using that, or I don't want to change the topic, but
yeah, nobody's using it. Okay.
This is the thing. I'd like to see Cozy in your various Forths for different architectures and so forth.
Yeah.
And there's a real nub of the vocabulary, which probably is only on the order of 20K.
Mm-hmm. All right. Thank you very much. Yeah.
Dr. Ting,
Yes.
I have a question for you. It's regarding this what do you call it? JavaScript, or actually more precisely, I would say is the browser execution of JavaScript. You see,
Yes.
what I did try a few years ago. It was, I think, 2018, right? You see, obviously, I'm sure you know that the JavaScript engine in the browser is actually written in C++, right? Now, so what I wanted to do was that I want to take a fourth program written in C or C++ and plug it into the Firefox source code directly. Okay, the inside Firefox source code, there is a JavaScript interpreter.
Mhm.
And what I wanted to do was I want to plug the fourth C++ or C code directly into the JavaScript
Mhm.
interpreter.
Yeah.
So I went through halfway, then I didn't go, much further. But I mean, since you started OoEforth and all these C, I mean, fourth based on C, right? So
Mhm.
what do you think? Do you think it might be actually more direct, if you like, like you said, you wanted the platform. I mean, that's my dream, because it's like I also implemented a kind of forth on top of JavaScript, right? So
Mhm.
I thought that instead of running on top of JavaScript, so since there are actually forth written in C, so why don't we just plug this forth directly into the JavaScript interpreter, let's say in Firefox, because Firefox code
Mhm.
is actually open source, and I spent a couple of months, I mean, maybe 3 or 4 months doing that in 2018. What's your opinion on that part?
Yeah. The JavaScript, the JE4th, JavaScript, the for E4th on JavaScript was implemented correctly. Okay. And I have tested out with very big applications. So the JE4th is JavaScript, and it is executed correctly under Chrome. Okay, I only tested on Chrome, but you might want to test it out Firefox or other platform. But the JE4 is correct. It's just that the JE4 is not, I mean, the JavaScript is not object oriented, okay? And it gives you some way to manipulate the arrays in the way that so that forth can be implemented correctly. And if it is totally object oriented, I think it would not work with the, I mean, the eForce would not work. But JE4, the JavaScript is not totally object oriented. And the JE, so in that sense, the JE4 work correctly. So I think JE4 can be ported to other browsers. I'm pretty sure. But,
Liang, I think something that you're asking about the question of whether to embed it in the browser, and I think one of the challenges is even if you do that successfully, now you have a browser that runs web pages that don't that has a language that isn't in other browsers, and so you have a compatibility problem and a build problem and a distribution problem, and so it's sort of like having a native fourth. Well, yeah, you can embed it in something else, but then the challenge would be, convincing others that this should be part of the platform. And
yeah.
What you can do, however, is write forth in whatever language you like, and then compile it to WebAssembly, or just write it directly in WebAssembly, and then it will run at nearly native speeds in any WASM compatible browser. Firefox, Chrome, so on and so forth.
James, the challenge of WebAssembly is that similar to it suffers. I think all of these languages suffer from the same problem, which is they they don't make a cheap computed go-to readily available to you. So it depends on your goal. If your goal is just, I want to run this abstract virtual machine on top, but unfortunately, there's not, the WebAssembly also suffers from this issue that you're not allowed to basically do a cross-function go-to. You can only do structured control flow, and this is sort of one of the design constraints that was placed on WebAssembly, because they were trying to make the underlying compiler able to do a bunch of optimizations, but it also has the downside that a language like Forth that relies on being able to do these chaining operations, and really any threaded interpreter has this problem on top of WebAssembly. It's not just Forth. So like Python implementations on top of WebAssembly have extra performance loss because of this.
Yeah, I think you have to consider the when you're using a platform for Forth, you have to adapt the Forth to that platform, and hopefully the platform is kind of universal, so that all the browser would behave the same, and then you implement Forth for the Chrome, and I would just hope that it would execute on other platforms, not worrying about the details of the platform. And you cannot carry the platform with you, okay? The platform is out there somewhere, okay? You can, if you implement anything, you are just only on something on the top of it. You can only move that part to other platforms. But as you say, if you want to move the entire platform with it, I think it is very difficult and impossible or impractical. Yeah. Okay, Kevin, I'm done. Where is Kevin?
I have a question though, Dr. Ting.
Yes.
Yeah, I'm not familiar with the for then next structure. I don't understand what that is and what it does.
Oh, I see.
This is different than, of course, all the questions about how to implement.
Yeah.
I'm just not familiar with that structure. I'd never seen that before.
Yeah, this is the one I'm deviated from the ANSI standard. Okay, so I'm instead of the the do loop. Okay, do loop is a standard way to implement loop, but for next is a different way. Okay.
Yes, no, I understand for next. I don't understand the then part in for next.
Oh, I see. So it is the for next. The problem is if you say 5 for next, you do execute 6 times. And that bothers lots of people. Okay. And so Chuck invented the aft then inside the for next loop. So if you have a for next inside it, it will skip that part the first time, and that would reduce the iteration by 1. Okay.
I see. Okay.
If you can 5, 4 after then next, then the part in the after then would only execute 5 times, and this just make people feel better.
It's another way of doing -1 before the 4.
Exactly.
Yeah. Okay. All right.
Yeah. I think Chuck apologized at one time in the SVFIG that he misled the Forth people by the do loop structure, because he basically copied the do loop in Fortran and implement it for the fourth. And that's a wrong choice. But he had no other alternate implementation. And after years, after he designed the 2 chips, and he finally realized do loop is the wrong implementation, because a do loop requires 2 parameters on the stack, and the for next requires only 1 parameter. Okay, and so the next can be implemented much more efficiently than do loop. So the next can be reduced to a single instruction and executed in a single cycle. And you just cannot do it with do loop. When you have two parameters, you have to compare and you have to do something and to decide when to exit the loop. It's very inefficient. So
Yeah, but it's even though the loop itself is inefficient, oftentimes I found that the for next is inefficient in the code in the middle of the do loop. There's a lot of times when you're manipulating the index a bunch in order to make it useful inside the do loop, and you do a lot of extra things that you wouldn't do with the do loop, the regular do loop. I'd like to see both around. I don't think you can lose both.
I don't agree. The do loop, the loop index is pushed off to the return stack, and the data stack you can use it any way you want. So it can be much more efficient than do loop. Okay. And
No. You don't understand. If you're using the index, if you're using the index for the loop,
yes.
which I use a lot, I find that I'm constantly doing math on the index in order to make it proper for inside the loop. You're right about the fact that the execution of the loop itself is very efficient, but I need it also to do things effectively inside, which is why the 2-parameter do loop can be much more useful in the inside the loop itself. Now, yeah, you can do the manipulation. I do it. I add extra words in there. I add extra things to make it work because I need them to work. But that doesn't mean that they're efficient. If I add 2 or 3 words inside the do loop, right, to compensate for the fact that I don't have the right form of the value in the do loop, I lose the efficiency that I got by the fact that the loop runs much faster. I certainly understand why he did it in his silicon, right? Because otherwise the silicon is really clumsy. But to sit there and say that because the loop itself is more efficient, that it's better, doesn't cover the whole operation of the things that you can do with a real do loop.
Yes.
Right.
I do not agree with you. Okay.
Okay. Well, we agree to not agree then.
I think that the loop is very efficient because the loop index is a single number on the return stack, and the data stack is still free. So anything you can do with the data stack, you can do it very efficiently. Okay. So I don't see any problem in using the inside the loop. You know, anything that can be done on the data stack, you can do it there very efficiently. Okay. And if you want to loop in that, you do the RFetch and you get it. Okay. So
no, I understand that. It's after I get the value of the RFetch, I have to do manipulation on that number to make it useful in the do loop.
Well,
that's what I'm complaining about. That's what I'm talking about. You're saying, yeah, it's there. All I have to do is grab it. But the number itself is the wrong number. Do you see what I'm saying? It's not the right number. I have to do something to it. I have to add or subtract 1, or I have to add some offset or do something else to it that I could have done at the entrance to the do loop. So that extra addition inside the do loop, if I have to do more than once that I have to correct that number, that more than once, which I do a lot, that more than once easily pays for the inefficiency of the do loop itself. Easily.
No,
Yeah.
I do not agree. I do not agree.
I can time it for you. I can show you. It's because everything costs something. You can't say it's a zero cost, because it's not. The minute I have to fiddle with the R, the returned R value off the stack, the minute I have to fiddle with that number, that I would have avoided by setting up the do loop correctly, the minute I do that, I've used up the advantage that I got on the more efficient do loop.
I think that Dwight should have a fourth that has Dwight's preferred do loop, and Ting should have a fourth that has Ting's preferred do loop. And we should move on.
Yes.
When you've seen 1/4, you've seen 1/4.
But in terms of the standard, you guys can both participate in whatever next round of standard, if there is one, and make the case for which one it should be.
Like I said, I understand why he did next on the chip.
Me too. I understand both of you. And
it's perfectly right for that chip. But to consider it as a general useful thing for all conditions is not true. It just isn't.
all right then. Ting, do you care to solicit any more comment on any other issues other than this one?
No, I'm done. I'm done. Okay, you take over. Yeah, the Dwight. I think the another comment is that the for next loop, the index runs backwards. Okay, so that's I think that's probably the problem you point out to. Okay, in the do loop, in the do loop, the index runs forward, and that's what the people used to. If you
that's only part of it.
Ting?
That's only part of it.
Can we table this, Dwight? Can we table this, Ting?
Sure. Okay.
I propose you guys can pick this up after Ragsdale's video has run. And those of you others that are interested in this discussion can remain. I believe this room will stay open until this time next month. So between now and then, I'm sure Dwight and Ting will get tired of talking about this. But I recommend you both participate in whatever standards team meeting or activity will be conducted in the interim, and make the case for your viewpoint on this subject, and decide which of the two viewpoints will be incorporated in the standard, or God help us, both of them. All right, on that cheerful note, I'm going to mute Dwight because I can, and suggest to Dave that he is the best person to run the Ragsdale video at this time.
As I mentioned, I think Brad might be in a position to run that as well. So,
okay.
If you have any objections.
I was expressing my opinion on the subject. Brad, are you online responding?
You need me for the next one? Yeah, I think I can do that.
All right, Dave.